What does it mean to home a machine? When an automated machine starts up, it doesn't generally know where each axis is currently positioned. Homing means moving that axis to a known physical position so that all future moves can be referenced to that known position. Even machines that use servos that can keep their encoders powered up using logic power backup, like ClearPath, sometimes need to home because logic power can fail, batteries can die, or the AC to the logic power supply can be lost. So the machine has to be able to find home. A common homing process moves the axis until it trips a proximity or optical sensor. When the sensor trips, ClearPath knows that the axis is at the switch location. It can call that position home or move a fixed offset from the switch and call that home. One problem with sensors is that the wiring often fails. You can get rid of the sensors completely, along with their cost and risk of failure, by using a popular ClearPath feature called hard stop homing. With this feature, ClearPath homes by driving toward a hard stop with a user-defined reduced torque limit. Using a sophisticated detection algorithm, it senses when it begins to press into the stop. Most axes have a rubber bumper at the end of travel, but the algorithm works well homing into a literal hard stop or a spring as well. Precision homing is a ClearPath feature that enhances the accuracy and repeatability of both hard stop and sensor homing. As mentioned earlier, the home position is relative to a known physical position that is detected by ClearPath during its homing routine. But what if, for example, the home sensor isn't very repeatable, or your hard stop becomes worn or dirty? The home position would naturally be less accurate and repeatable. But now, with ClearPath firmware 2.0 and above, a feature called precision homing solves this problem. I'm currently set to home every time I enable the motor. So I'll home the axis again by turning the enable input off and then on again. This dial indicator shows the current home position. I've zeroed it so we can easily see if the home position changes. If I turn off precision homing and home the axis again, inserting a shim in front of the hard stop, the home position now has an error equal to the thickness of the shim. But if I turn on precision homing and try to induce the same error again, the original home position is set perfectly. Even a relatively large error can be corrected by precision homing. Let's see what happens if we home with the hard stop bumper missing. Precision homing still sets the home position accurately. So that's it. I hope this TekTips overview of homing and precision homing has been interesting and useful. If so, please click the like button to let other ClearPath users know. If you want to get notified whenever we release a new video, click the Teknic logo right now to subscribe. As always, we welcome your comments, questions, and suggestions. Thanks for watching.